What if the ocean floor could be understood without maps, names, or measurements, only through the shapes it forms? Across a continuous field of structures, patterns begin to appear. Some extend in precise alignment. Others gather, disperse, or overlap. Certain forms rise into defined peaks, while others remain level or transition between multiple structural types. These patterns repeat across different regions, yet remain consistent when viewed only through geometry and arrangement. This video follows a classification system built entirely on structural form. It organizes submarine features into clear categories based on shape, vertical profile, and spatial configuration. No interpretation, no process, only observable structure arranged into a stable framework. Each section presents a different way these forms can be grouped and compared within the same system. If you find this kind of structured perspective useful, consider subscribing to the channel. You can also leave a like and share your observations or questions in the comments below. Grammariform category groupings establish a high-level partitioning of submarine structural forms using broad morphological distinctions. These groupings operate as generalized classification sets that separate features according to overall structural type, rather than specific attributes. Each category reflects a consistent pattern of physical form that can be identified without reliance on measurement systems or regional context. Elevated structures form one primary grouping, including features that extend upward relative to surrounding surfaces. Depressed structures represent another grouping, defined by downward extension relative to adjacent areas. Planar forms are identified as surfaces with minimal vertical variation across their extent. These categories remain distinct without reference to scale or geographic placement. Linear structural groupings include forms characterized by extended alignment along a dominant axis. Non-linear groupings include forms without a single directional orientation. Isolated structural categories include features that appear as singular entities without direct connection to adjacent forms. Connected structural categories include features that form part of continuous or linked systems. Discrete categories are maintained based on surface continuity, separating uninterrupted forms from segmented or discontinuous structures. Additional groupings distinguish between simple forms composed of a single structural type and composite forms that include multiple structural elements. These primary groupings remain consistent across global contexts and provide a stable reference framework for further classification. Basin scale form classification sets organized submarine structural forms into broad categories associated with large oceanic domains. These sets operate at a scale where individual features are grouped according to their general structural role within basin-wide contexts. Classification remains independent of specific geographic naming and does not rely on numerical thresholds. Central basin categories include extensive planar forms and low-relief surfaces that occupy large continuous areas. Peripheral basin categories include structural forms positioned along basin margins, where transitions between major structural types are observed. Intermediate basin categories include forms situated between central and marginal domains, forming transitional classification groups without implying process relationships. Elevated basin scale groupings include large structural rises and extended ridge systems that span significant portions of basin interiors. Depressed basin scale groupings include broad trough-like and basin-like structures that define lower structural regions across wide areas. These groupings remain separated based on overall structural orientation rather than localized variation. Continuous basin-wide categories include forms that extend across large uninterrupted regions, maintaining consistent structural identity. Segmented basin scale categories include forms divided into discrete sections while retaining a shared classification grouping. Distributed basin sets include forms that appear across multiple separated locations while maintaining similar structural characteristics. These classification sets provide a consistent framework for organizing submarine forms at a basin-wide level. Each set remains defined by general structural placement and form type, without reference to regional distinctions or measurement-based criteria. Linear form categories group submarine structures that exhibit a dominant directional extension along a single axis. These forms maintain consistent alignment over their length and are identified by their elongated configuration. The classification remains based on overall geometric orientation rather than variation in size or location. Non-linear form categories group structures that do not follow a single directional axis. These forms exhibit multi-directional extension or lack a consistent alignment pattern. Their classification is determined by the absence of dominant linear continuity rather than by specific geometric complexity. Linear categories include structures that appear as continuous or segmented alignments, maintaining a recognizable directional trend across their extent. Some linear forms are uninterrupted, where others are divided into sections that retain a shared axis. Alignment consistency is used as a primary distinguishing feature within this category. Non-linear categories include forms with radial, clustered, or irregular spatial configurations. These structures do not conform to a single axis and may expand outward or occupy space without directional preference. The classification is based on overall spatial arrangement rather than internal composition. Boundary distinctions between linear and non-linear categories are defined by the presence or absence of axis-dominant structure. Transitional forms may display partial alignment without full directional consistency, but classification remains assigned according to predominant structural pattern. These categories provide a consistent global reference for distinguishing directional structure in submarine form classification. Elevation-based category divisions classify submarine structural forms according to their relative vertical position compared to adjacent surfaces. These divisions operate as broad groupings that distinguish forms based on upward or downward extension, without reference to measured values. The classification remains consistent across global contexts through relative comparison rather than absolute depth. Elevated categories include structural forms that extend above surrounding reference surfaces. These forms are identified by positive vertical differentiation and are grouped independently of their horizontal extent. Depressed categories include forms that extend below adjacent surfaces and are defined by negative vertical differentiation. Intermediate elevation categories include forms that occupy positions between elevated and depressed extremes. These categories represent structures with limited vertical contrast relative to surrounding areas. Planar elevation categories include forms with minimal vertical variation, maintaining consistent height across their extent. Subdivisions within elevation-based categories distinguish between continuous vertical transitions and abrupt vertical changes. We find this: some forms display gradual elevation variation across their structure, while others exhibit distinct breaks in vertical profile. These distinctions remain within the broader elevation-based grouping framework. Composite elevation categories include structures that contain both elevated and depressed components within a single form. These categories are defined by the coexistence of multiple vertical relationships rather than by isolated characteristics. All elevation-based divisions rely on relative positioning and maintain separation from measurement-based classification systems. Surface continuity classification types group submarine structural forms according to the degree of uninterrupted surface extension across their extent, These classifications distinguish forms based on whether their surface remains continuous or is divided into separate segments. The grouping operates independently of scale and does not rely on geographic placement. Continuous surface categories include forms that maintain an unbroken structural surface across their full extent. These forms are identified by the absence of interruptions or separations in their surface structure. The continuity is recognized through consistent structural connection across adjacent areas. Discontinuous surface categories include forms that are divided into distinct segments or sections. These segments may be separated by gaps or structural breaks while retaining a shared classification grouping. The presence of separation defines the category rather than the nature of the segments themselves. Partially continuous categories include forms that exhibit both uninterrupted and segmented characteristics within the same structure. These forms contain areas of continuous surface alongside areas of separation. Classification is assigned based on the coexistence of these surface conditions. Additional distinctions include forms with regular segmentation patterns and forms with irregular surface interruptions. Regular segmentation categories include forms divided into repeating structural units. Irregular segmentation categories include forms with non-uniform surface breaks. All surface continuity classification types rely on the structural relationship between connected and separated surface areas. These categories provide a consistent framework for distinguishing forms based on surface structure without reference to measurement systems or regional context. Isolated versus connected form groups classify submarine structural forms based on the presence or absence of direct structural linkage to adjacent features. These groupings distinguish whether a form exists as a discrete entity or as part of a larger interconnected system. The classification remains independent of spatial scale and geographic context. Isolated form groups include structures that appear as singular entities without continuous structural connection to surrounding forms. These forms are identified by clear separation from adjacent features and maintain distinct boundaries. The classification is based on structural independence rather than relative position. Connected form groups include structures that are physically linked to other forms through continuous or sequential extension. These connections may occur along linear alignments or through broader structural networks. The defining characteristic is the presence of uninterrupted linkage between adjacent components. Subcategories within connected groups include continuous systems and segmented systems. Continuous systems maintain an unbroken structural connection across their extent. Segmented systems consist of multiple connected units separated by minor discontinuities while retaining overall linkage. Transitional groupings include forms that exhibit partial connection, where structural linkage is present but not continuous across the entire form. These forms are classified according to the dominant structural relationship, either isolated or connected, based on overall configuration. All classifications within this grouping rely on structural connectivity as the primary criterion. The distinction between isolated and connected forms provides a consistent framework for organizing submarine structures based on their relational configuration, without reference to measurement systems or regional variation. Planar form shape categories classify submarine structures that exhibit minimal vertical variation across their surface. These forms are defined by their broadly level configuration and the absence of pronounced elevation differences within their extent. The classification is based on geometric uniformity rather than size or spatial placement. Flat surface categories include forms with consistent surface elevation across large areas. These structures maintain a uniform geometric profile without distinct peaks or depressions. The defining characteristic is the continuity of a level surface across the form. Gently undulating planar categories include forms that display slight variations in surface elevation, while retaining an overall planar character. These variations do not produce distinct structural features and remain within a limited range of vertical difference. The classification remains within planar categories due to the dominance of surface uniformity. Segmented planar categories include forms that consist of multiple adjacent flat surfaces, separated by minor breaks. Each segment retains planar characteristics, while the overall structure includes discontinuities between sections. The classification is determined by the presence of planar segments rather than complete surface continuity. Bounded planar categories include forms with clearly defined edges, separating them from adjacent non-planar structures. These boundaries are identified by changes in surface geometry rather than by measurement. Unbounded planar categories include forms that transition gradually into surrounding structures without distinct edge definition. All planar form shape categories rely on the geometric condition of low vertical variation. These categories provide a consistent framework for identifying surface-based structural forms without reference to dimensional measurement or spatial distribution patterns. Conical and dome-shaped structures are classified based on curved surface geometry that extends upward from a base area toward a central point or rounded summit. These forms are identified by radial symmetry and a continuous change in surface inclination from base to apex or crest. The classification relies on overall geometric configuration rather than scale or spatial context. Conical categories include structures with a defined apex and sloping sides that converge toward a central point. These forms maintain a consistent directional gradient from the base to the top. The outline appears angular in profile, with a clear transition from base perimeter to apex. Dome-shaped categories include structures with a rounded summit and smoothly curved surface extending outward in all directions. These forms lack a sharp apex and instead display a broad upper surface. The curvature remains continuous without abrupt angular transitions. Subcategories within these groupings distinguish between symmetrical and asymmetrical forms. Symmetrical forms maintain uniform geometry around a central axis. Asymmetrical forms display uneven curvature or variation in slope across different sides, while retaining overall conical or dome-like classification. Additional distinctions include single-peak forms and multi-peak variations within a unified base structure. Some forms exhibit a singular central high point, while others contain multiple elevated points, connected within the same geometric boundary. All conical and dome-shaped classifications are defined by curvature and radial organization. These categories provide a consistent framework for identifying rounded and peak-based structures without reference to dimensional measurement or distribution patterns. Ridge-like elongated forms are classified by their extended geometry along a dominant axis combined with a raised structural profile relative to adjacent surfaces. These forms are identified by their lengthwise continuity and consistent directional alignment. The classification is based on overall shape and orientation rather than dimensional extent. Primary ridge-like categories include structures with a continuous crest line extending along a single axis. These forms maintain a recognizable linear configuration with elevation concentrated along a central axis. The surface transitions downward on either side of the crest, forming a consistent, elongated profile. Segmented ridge-like categories include structures composed of multiple aligned sections separated by minor discontinuities. Each segment retains ridge-like characteristics, while the overall structure maintains directional alignment across its extent. The classification remains based on continuity of alignment rather than uninterrupted surface connection. Broad ridge categories include forms with an expanded crest region that extends laterally while preserving elongated geometry. Narrow ridge categories include forms with a confined crest zone and sharper lateral transitions. These distinctions are defined by geometric proportion without reliance on measurement. Irregular ridge-like categories include structures with variable alignment or changes in crest direction, while maintaining an overall elongated configuration. These forms may exhibit curvature or deviation from a straight axis, while retaining ridge-based classification. All ridge-like elongated forms are defined by the combination of linear extension and elevated central structure. These categories provide a consistent framework for identifying elongated raised forms without reference to spatial distribution or metric systems. Depressed basin-like structures are classified by their inward sloping geometry that forms a concave surface relative to surrounding areas. These forms are identified as a central low region enclosed by higher structural boundaries. The classification is based on overall shape and curvature rather than depth or spatial extent. Primary basin-like categories include structures with a clearly defined central depression and continuous inward gradient from surrounding edges. These forms exhibit a unified concave profile, with surface inclination directed toward a central zone. The boundary is identified through a change in slope orientation from outward to inward. Broad basin categories include forms with a wide, gently curved interior surface. These structures display gradual transitions from perimeter to central area while maintaining a consistent concave geometry. Steep-sided basin categories include forms with more abrupt transitions along their margins and a more defined interior boundary. Closed basin-like categories include structures with fully enclosed boundaries, forming a continuous perimeter around the central depression. Open basin-like categories include forms where the boundary is incomplete or merges gradually with adjacent structures. The classification is determined by boundary definition rather than enclosure scale. Complex basin categories include structures containing multiple internal depressions within a shared outer boundary. Simple basin categories include forms with a single central depression and uniform internal geometry. These distinctions remain based on internal structural arrangement, without reference to measurement. All depressed basin-like structures are defined by concave geometry and inward surface orientation. These categories provide a consistent framework for identifying depression-based forms using shape characteristics alone. Irregular and composite shapes are classified by the absence of a single consistent geometric form or by the integration of multiple distinct shape elements within one structure. These forms are identified through variation in surface geometry and the coexistence of differing structural patterns. The classification is based on overall geometric complexity rather than uniform shape definition. Irregular shape categories include structures that do not conform to standard geometric types, such as planar, conical, or linear forms. These structures exhibit variable curvature, uneven boundaries, and inconsistent surface transitions. The classification is determined by the lack of repeatable geometric pattern across the form. Composite shape categories include structures that combine two or more recognizable geometric types within a unified configuration. These forms may include combinations of elevated and depressed elements, or linear and nonlinear components. The defining feature is the presence of multiple geometric identities within a single structural boundary. Subcategories distinguish between integrated composites and juxtaposed composites. Integrated composites include forms where different geometric elements merge gradually into each other. Juxtaposed composites include forms where distinct geometric elements remain separate but occur in close association. Additional distinctions include forms with hierarchical geometric organization and forms with non-hierarchical arrangement. Hierarchical composites display dominant and subordinate shape elements within the same structure. Non-hierarchical composites present multiple elements without a dominant geometric form. All irregular and composite shapes are defined by geometric variability and multi-form integration. These categories provide a consistent framework for identifying complex structural forms without reference to dimensional measurement or spatial distribution. Symmetry-based classification types group submarine structural forms according to the presence and arrangement of geometric balance across one or more axes. These classifications are determined by the degree to which a form can be divided into equivalent parts through reflection or rotation. The framework relies on geometric correspondence rather than dimensional properties or spatial placement. Radial symmetry categories include forms organized around a central point, where structural elements extend outward in multiple directions with consistent geometric relationships. These forms maintain uniformity around a central axis and display repeated structural patterns across angular divisions. Bilateral symmetry categories include forms that can be divided into two corresponding halves along a single axis. Each side reflects the structure of the other, maintaining proportional alignment across the dividing line. The classification is based on mirrored geometry rather than identical surface detail. Asymmetrical categories include forms that do not exhibit consistent geometric balance across any axis. These structures display uneven distribution of surface features and lack repeatable correspondence between different sides. The classification is defined by the absence of symmetry rather than the presence of irregularity alone. Subcategories distinguish between partial symmetry and full symmetry. Partial symmetry includes forms where symmetry is present in limited sections, but not across the entire structure. Full symmetry includes forms where geometric balance is maintained throughout the entire configuration. All symmetry-based classification types rely on geometric correspondence and axis-based organization. These categories provide a consistent framework for identifying structural balance in submarine forms without reference to measurement or distribution patterns. High-relief structural categories group submarine forms characterized by pronounced vertical differentiation between their highest and lowest points. These categories are defined by strong elevation contrast within a single structure, resulting in distinct vertical profiles. The classification relies on relative elevation variation rather than measured values. Forms within this category include structures with steep gradients extending from base regions to elevated points. The vertical transition is clearly defined, with noticeable separation between upper and lower structural levels. The profile often includes concentrated elevation zones that define the overall structure. Additional groupings include forms with multiple high-relief segments arranged within a unified structure. These segments may appear as repeated elevated zones separated by lower areas while maintaining overall vertical contrast. The classification remains based on the presence of significant elevation differences across the structure. High-relief categories also include forms with sharp transitions between adjacent surfaces. These transitions create distinct boundaries between elevation nulls without gradual slope progression. In contrast, some high-relief forms maintain steep but continuous gradients without abrupt breaks. Subcategories distinguish between localized high-relief structures and extended high-relief systems. Localized forms contain concentrated elevation within a limited area. Extended forms maintain significant vertical differentiation across a broader structural extent. All high-relief structural categories are defined by strong vertical variation and distinct elevation contrast. These categories provide a consistent framework for identifying forms with pronounced vertical profiles without reference to formation processes or sediment influence. Low-relief surface forms are classified by limited vertical variation across their structure, resulting in minimal contrast between higher and lower areas. These forms are identified by gradual elevation differences that do not produce distinct vertical features. The classification is based on relative uniformity in vertical profile, rather than measured height. Primary low-relief categories include surfaces that maintain near-level elevation across their extent. These forms display consistent vertical positioning with only slight variation in surface height. The overall profile remains subdued, without prominent elevation changes. Additional categories include gently inclined surfaces that exhibit gradual slope without sharp transitions. These forms maintain continuity in vertical change, with no abrupt breaks or concentrated elevation zones. The slope remains consistent across the structure, contributing to a uniform profile. Segmented low-relief categories include forms composed of multiple areas with slight elevation differences, where each segment retains low-relief characteristics. The transitions between segments are minor and do not create distinct structural divisions. The classification remains within low relief due to the absence of strong vertical contrast. Subcategories distinguish between uniform low-relief surfaces and irregular low-relief forms. Uniform types maintain consistent elevation across the entire structure. Irregular types include minor variations in surface height while preserving overall low-relief classification. All low-relief surface forms are defined by reduced vertical differentiation and continuous surface gradients. These categories provide a consistent framework for identifying structures with subdued vertical profiles, without reference to formation processes or sediment influx. Steep gradient profile groups classify submarine structural forms characterized by rapid vertical change over a short horizontal distance. These forms are identified by sharp inclines that create a pronounced transition between different elevation levels. The classification is based on the intensity of slope, rather than measured angle or height. Primary categories include forms with continuous steep slopes extending from lower to higher structural positions. These structures maintain a consistent gradient across their profile, with no extended areas of low inclination. The surface transitions remain direct and clearly defined. Additional categories include forms with abrupt slope transitions, where steep gradients occur over limited sections of the structure. These transitions create distinct zones of rapid elevation change adjacent to areas of reduced slope. The classification remains within steep gradient groups due to the presence of concentrated incline segments. Segmented steep gradient categories include structures composed of multiple steep sections separated by intervals of lesser slope. Each segment retains a sharp incline, while the overall structure presents alternating gradient patterns. The grouping is determined by the recurrence of steep profile elements. Subcategories distinguish between uniform steep gradients and variable steep gradients. Uniform types maintain consistent slope intensity across the structure. Variable types include changes in gradient magnitude while preserving overall steep profile characteristics. All steep gradient profile groups are defined by pronounced slope intensity and rapid elevation transition. These categories provide a consistent framework for identifying sharply inclined structural forms without reference to formation processes or sediment influence. Gradual slope profile types classify submarine structural forms that exhibit continuous elevation change across extended surfaces without abrupt transitions. These forms are identified by moderate to low incline intensity distributed evenly across the profile. The classification is based on the character of slope progression rather than measured gradient values. Primary gradual slope types include forms with uniform incline from one structural level to another. These profiles maintain consistent surface transition across their extent and do not contain concentrated zones of rapid elevation change. The overall geometry appears continuous and uninterrupted in vertical progression. Additional types include Forms with broad curved slopes, where elevation changes through a smooth profile rather than along straight planar surfaces. These structures retain gradual transition characteristics while differing in surface geometry. The classification remains based on the absence of abrupt slope breaks. Segmented gradual slope types include forms composed of multiple, gently inclined sections connected in sequence. Each section preserves a gradual profile, and the transitions between sections remain moderate rather than sharp. The grouping is determined by the continuity of reduced slope intensity across the structure. Subcategories distinguish between symmetrical gradual slopes and asymmetrical gradual slopes. Symmetrical types display similar incline patterns on opposing sides of a central profile. Asymmetrical types include differing slope lengths or incline distribution, while retaining an overall gradual character. All gradual slope profile types are defined by steady vertical transition and limited slope intensity variation. These categories provide a consistent framework for identifying forms with extended and moderated profile change without reference to formation processes or sediment influence. Flat top versus peaked profiles classify submarine structural forms based on the geometry of their uppermost surface. These categories distinguish between forms that terminate in a level surface and those that converge to a defined high point. The classification relies on summit configuration rather than overall height or slope measurement. Flat top profile categories include structures with a broad, level upper surface that extends across a defined area. These forms exhibit minimal vertical variation at their highest structural level. The transition from side slopes to the upper surface is marked by a change from inclined geometry to a planar configuration. Peaked profile categories include structures that converge toward a central high point or narrow crest. These forms display continuous upward inclination without forming an extended flat surface at the top. The summit is defined by a localized maximum rather than an area of uniform elevation. Subcategories within flat top profiles include forms with sharply defined edges between the upper surface and surrounding slopes, as well as forms with gradual transitions into the flat region. Subcategories within peaked profiles include forms with singular apex points and forms with short crest lines rather than a single point. Additional distinctions include composite profiles, where flat top and peaked characteristics coexist within the same structure. These forms may include a central peak rising from a broader flat surface or multiple peaks distributed across a level upper region. All classifications within this grouping are defined by summit geometry and upper surface structure. These categories provide a consistent framework for identifying profile termination types without reference to formation processes or sediment influence. Multi-level vertical structures are classified by the presence of multiple distinct elevation tiers within a single submarine form. These structures are identified by stepwise or layered vertical organization, where different levels are separated by changes in slope or elevation continuity. The classification is based on the arrangement of vertical segments rather than total height. Primary categories include tiered structures with clearly defined levels stacked in sequence. Each level maintains a relatively consistent elevation before transitioning to the next. The transitions between levels may appear as abrupt breaks or as short gradient zones separating adjacent tiers. Additional categories include irregular multi-level forms, where vertical segments vary in size and arrangement. These structures contain multiple elevation zones without uniform spacing or consistent repetition. The classification remains based on the presence of multiple vertical divisions within a unified form. Stepped profile categories include structures with repeated elevation intervals, forming a sequence of levels. These forms display a patterned arrangement of vertical tiers. Non-patterned multi-level categories include forms where elevation changes occur without consistent repetition across the structure. Subcategories distinguish between continuous multi-level systems and segmented multi-level systems. Continuous types maintain structural connection across all levels without separation. Segmented types include breaks or discontinuities between vertical sections, while retaining overall multi-level organization. All multi-level vertical structures are defined by layered elevation configuration and the presence of multiple vertical reference points. These categories provide a consistent framework for identifying vertically complex forms without reference to formation processes or sediment influence. Clustered structural groupings classify submarine forms based on their spatial concentration within a defined area. These groupings are identified by the presence of multiple structural elements located in close proximity, forming a collective arrangement. The classification is based on spatial density and grouping pattern, rather than individual form characteristics. Primary clustered categories include tightly grouped structures with minimal separation between adjacent elements. These clusters exhibit high structural density, with individual forms positioned near one another across a limited spatial extent. The grouping is defined by proximity and repetition of similar structural units. Loose cluster categories include structures that remain grouped within a broader area, but display greater spacing between individual elements. These groupings maintain overall clustering while allowing for variation in distance between components. The classification remains within clustered types due to consistent spatial association. Subcategories distinguish between uniform clusters and irregular clusters. Uniform clusters include forms distributed with relatively consistent spacing and arrangement. Irregular clusters include forms with uneven spacing and variable positioning, while maintaining overall grouping. Additional distinctions include single-type clusters and mixed-type clusters. Single-type clusters consist of similar structural forms repeated within the grouping. Mixed-type clusters include different structural forms occurring together within the same clustered arrangement. All clustered structural groupings are defined by spatial concentration and collective arrangement. These categories provide a consistent framework for identifying grouped structures without reference to geographic naming or basin-specific mapping. Linear alignment configurations classify submarine structural forms based on their arrangement along a consistent directional axis. These configurations are identified by the sequential positioning of individual forms that collectively establish a linear pattern. The classification is based on alignment continuity rather than individual form geometry. Primary linear configurations include structures arranged in a continuous sequence along a single axis. These arrangements maintain consistent directional orientation across their extent, with each element positioned in relation to the same alignment trend. The overall pattern remains identifiable as a unified linear configuration. Segmented linear configurations include structures aligned along a common axis but separated by intervals. Each segment retains directional consistency, while the overall arrangement includes gaps between elements. The classification remains based on alignment, rather than continuity of connection. Curvilinear alignment categories include configurations where the linear arrangement follows a curved path rather than a straight axis. These forms maintain directional progression while exhibiting gradual changes in orientation. The classification is determined by continuous alignment along a nonlinear path. Subcategories distinguish between uniform alignment spacing and variable alignment spacing. Uniform configurations include elements distributed at relatively consistent intervals. Variable configurations include irregular spacing while maintaining overall directional coherence. Additional distinctions include single-row alignments and multi-row parallel alignments. Single-row configurations consist of one sequence of aligned forms. Multi-row configurations include parallel sequences maintaining similar directional orientation. All linear alignment configurations are defined by directional arrangement and positional sequence. These categories provide a consistent framework for identifying aligned structural patterns without reference to geographic naming or basin-specific mapping. Radial distribution patterns classify submarine structural forms based on their arrangement around a central reference point. These patterns are identified by outward positioning of structural elements in multiple directions, forming a circular or spoke-like configuration. The classification is based on directional dispersion relative to a central location, rather than individual form characteristics. Primary radial patterns include structures distributed evenly around a central point, maintaining consistent spacing and directional balance. These arrangements exhibit uniform angular separation between elements, creating a symmetrical radial configuration. The overall pattern remains centered and evenly organized. Irregular radial patterns include structures arranged around a central point with variable spacing and directional distribution. These configurations retain a central reference but display uneven positioning of individual elements. The classification remains radial due to the outward orientation from a shared center. Concentric radial categories include structures arranged in circular bands around a central point. Each band forms a ring-like distribution, with multiple layers extending outward. The classification is defined by repeated circular arrangement rather than linear alignment. Spoke-based radio categories include structures extending outward along defined directional lines from a central point. These forms create a pattern of radiating alignments, with elements positioned along distinct axes. Subcategories distinguish between single-center radial patterns and multi-center radial arrangements. Single-center types maintain one central reference point. Multi-center types include overlapping radial patterns with multiple focal points. All radial distribution patterns are defined by outward arrangement from central reference points. These categories provide a consistent framework for identifying circular and radiating structural configurations without reference to geographic naming or basin-specific mapping. Dispersed form arrangements classify submarine structural forms based on their distribution across a wide area without consistent proximity or alignment. These arrangements are identified by the separation of individual forms and the absence of grouping patterns. The classification is based on spatial dispersion rather than structural similarity. Primary dispersed categories include forms distributed with large intervals between individual elements. These structures do not exhibit clustering or linear alignment and appear independently across the distribution area. The arrangement is defined by separation rather than connection. Random dispersed categories include forms positioned without consistent spacing or directional pattern. These configurations display irregular placement with no repeating arrangement or identifiable structural sequence. The classification remains based on the lack of organized distribution. Uniform dispersed categories include forms distributed with relatively consistent spacing across an area while maintaining separation. These arrangements exhibit regular intervals between elements, but do not form clusters or alignments. The defining feature is balanced spacing without grouping. Subcategories distinguish between single-type dispersed arrangements and mixed-type dispersed arrangements. Single-type arrangements include similar structural forms distributed independently. Mixed-type arrangements include different structural forms occurring across the same dispersed field. Additional distinctions include isolated point distributions and broad field distributions. Isolated point types include widely spaced individual forms. Broad field types include larger numbers of forms distributed across an extended area without forming structured patterns. All dispersed form arrangements are defined by separation and lack of organized configuration. These categories provide a consistent framework for identifying independently distributed structures without reference to geographic naming or basin-specific mapping. Boundary-aligned structures classify submarine forms based on their arrangement along defined structural edges or transitional zones between adjacent areas. These configurations are identified by the positioning of forms that follow a boundary line separating differing structural regions. The classification is based on alignment relative to a boundary rather than individual form characteristics. Primary boundary-aligned categories include structures arranged continuously along a defined edge. These forms maintain consistent positioning adjacent to the boundary, creating a recognizable alignment pattern that follows its outline. The configuration remains defined by proximity to the boundary line. Segmented boundary-aligned categories include structures positioned along a boundary with interruptions between elements. These forms retain alignment relative to the boundary while exhibiting gaps in continuity. The classification remains based on consistent boundary association. Curvilinear boundary-aligned categories include structures following boundaries that change direction across their extent. These configurations maintain alignment while adapting to variations in boundary geometry. The defining feature is continuous correspondence with the boundary shape. Subcategories distinguish between single boundary alignment and dual boundary alignment. Single boundary types include forms associated with one structural edge. Dual boundary types include forms positioned between or along two parallel or intersecting boundaries. Additional distinctions include uniform boundary spacing and variable boundary spacing. Uniform configurations include structures distributed at consistent intervals along the boundary. Variable configurations include irregular spacing while maintaining overall alignment. All boundary-aligned structures are defined by their positional relationship to structural edges. These categories provide a consistent framework for identifying alignment patterns associated with boundaries without reference to geographic naming or basin-specific mapping. Interior basin distribution types classify submarine structural forms based on their placement within central basin regions, away from boundary-aligned zones. These configurations are identified by the positioning of forms within interior areas that do not correspond to edge-defined arrangements. I have the power. The classification is based on spatial placement relative to basin interior zones, rather than individual structural characteristics. Primary interior distribution categories include forms dispersed across central basin areas without consistent alignment or clustering. These structures occupy interior space independently, maintaining separation from boundary-associated patterns. The arrangement is defined by interior positioning rather than proximity to edges. Centralized interior categories include forms concentrated around interior focal areas within the basin. These configurations exhibit localized grouping within central regions, while remaining distinct from boundary-related arrangements. The classification remains based on interior concentration patterns. Uniform interior distribution categories include forms positioned across interior areas with relatively consistent spacing. These arrangements display balanced distribution without forming linear or clustered configurations. The defining feature is even placement within the interior zone. Subcategories distinguish between single-type interior distributions and mixed-type interior distributions. Single-type distributions include similar forms occupying interior regions. Mixed-type distributions include multiple structural forms occurring within the same interior space. Additional distinctions include continuous interior fields and segmented interior fields. Continuous types include forms distributed across uninterrupted interior areas. Segmented types include interior regions divided into separate zones. while maintaining interior classification. All interior basin distribution types are defined by placement within central basin areas and the absence of boundary alignment. These categories provide a consistent framework for identifying interior spatial arrangements without reference to geographic naming or basin-specific mapping. Overlapping form combinations classify submarine structures where multiple distinct forms occupy the same spatial extent and intersect across shared areas. These configurations are identified by the superposition of structural elements that retain identifiable characteristics while partially covering one another. The classification is based on spatial overlap rather than sequential arrangement. Primary overlapping categories include forms where one structural element extends across the surface of another, creating a layered configuration. Each element maintains its geometric identity while sharing common space with adjacent forms. The overlap may occur across entire sections or within localized regions. Partial overlap categories include structures where intersection occurs only within specific portions of each form. These configurations retain areas of independent structure alongside zones of shared spatial occupation. The classification is determined by the presence of intersecting regions rather than complete coverage. Multiform overlap categories include structures involving more than two forms intersecting within the same area. These arrangements produce complex overlapping patterns, where multiple geometric elements coexist within a unified spatial boundary. The classification remains based on the degree of shared spatial occupation. Subcategories distinguish between ordered overlap and irregular overlap. Ordered overlap includes forms arranged with consistent layering or repeated intersection patterns. Irregular overlap includes forms intersecting without consistent arrangement or repetition. Additional distinctions include surface-level overlap and volumetric overlap. Surface-level types involve intersection across outer structural surfaces. Volumetric types include deeper integration, where overlapping forms extend across multiple structural levels. All overlapping form combinations are defined by shared spatial occupation and intersecting geometry. These categories provide a consistent framework for identifying superimposed structural forms without reference to temporal change or geological interaction. Nested structural configurations classify submarine forms, where one structural element is enclosed within the boundaries of another. These configurations are identified by hierarchical spatial containment, where inner forms occupy defined positions inside larger enclosing structures. The classification is based on enclosure relationships rather than overlap or adjacency. Primary nested categories include structures with a single inner form contained within a larger outer boundary. The inner element maintains distinct geometric identity while remaining fully enclosed by the surrounding structure. The outer form provides a continuous boundary that defines the nested arrangement. Multiple-level nested categories include configurations where several layers of forms are arranged in successive enclosure. Each level contains or is contained by another, creating a tiered spatial hierarchy. The classification is determined by the presence of repeated enclosure relationships across multiple levels. Partial nesting categories include structures where the inner form is enclosed within a portion of the outer boundary, rather than its entirety. These configurations retain identifiable containment, while allowing parts of the inner structure to extend beyond the enclosing form. The classification remains based on dominant enclosure characteristics. Subcategories distinguish between symmetrical nesting and asymmetrical nesting. Symmetrical nesting includes inner forms positioned centrally within the enclosing structure. Asymmetrical nesting includes offset positioning within the outer boundary while maintaining containment. Additional distinctions include simple nested configurations and complex nested configurations. Simple types include one level of enclosure between two forms. Complex types include multiple inner elements contained within a single outer structure. All nested structural configurations are defined by enclosure and hierarchical arrangement. These categories provide a consistent framework for identifying contained structural relationships without reference to temporal change or geological interaction. Transitional form categories classify submarine structures that exhibit intermediate characteristics between distinct geometric or structural types. These forms are identified by the presence of gradual shifts in shape or configuration across their extent. The classification is based on hybrid structural expression rather than fixed geometric identity. Primary transitional categories include forms that display continuous variation from one structural type to another. These structures maintain identifiable features of multiple categories within a single configuration. The transition occurs across the form without distinct separation between structural types. Segmented transitional categories include structures where different form characteristics appear in adjacent sections. Each section retains a recognizable structural identity, while the overall configuration reflects a combination of types. The classification remains transitional due to the coexistence of differing forms within one structure. Gradient-based transitional categories include forms where geometric characteristics change progressively across the structure. These changes occur without abrupt boundaries, resulting in a smooth shift between structural expressions. The classification is defined by continuous variation rather than discrete segments. Subcategories distinguish between balanced transitional forms and dominant transitional forms. Balanced types include forms where multiple structural characteristics are present in comparable proportions. Dominant types include forms where one structural type prevails, while secondary characteristics remain identifiable. Additional distinctions include simple transitional configurations and complex transitional configurations. Simple types involve transition between two structural categories. Complex types include multiple overlapping transitions across different parts of the structure. All transitional form categories are defined by intermediate structural categories and the integration of multiple geometric types. These categories provide a consistent framework for identifying hybrid configurations without reference to temporal change or geological interaction. Hybrid geometry classifications group submarine structures that combine distinct geometric forms into a single integrated configuration. These classifications are defined by the coexistence of multiple geometric characteristics that remain identifiable within one structure. The grouping is based on combined shape attributes rather than transitional variation. Primary hybrid categories include forms that incorporate both planar and elevated geometries within a unified structure. These configurations present flat surface areas alongside raised structural components. We see how warm labor, old men may have children. The classification is determined by the simultaneous presence of differing geometric types. Additional hybrid categories include combinations of linear and non-linear geometries within the same form. These structures may include elongated segments connected to non-directional or irregular components. The classification remains based on the integration of contrasting geometric patterns. Composite curvature categories include forms that combine angular and rounded surface elements. These configurations display both sharp geometric transitions and smooth curved surfaces within a single structural boundary. The defining feature is the coexistence of differing curvature types. Subcategories distinguish between balanced hybrid configurations and dominant hybrid configurations. Balanced types include forms where multiple geometric elements are present in comparable proportions. Dominant types include forms where one geometric characteristic is more prominent, while secondary elements remain identifiable. Additional distinctions include simple hybrid configurations involving two geometric types and complex hybrid configurations involving multiple geometric combinations. These classifications remain based on structural integration rather than sequential transformation. All hybrid geometry classifications are defined by the integration of multiple geometric forms within a single structure. These categories provide a consistent framework for identifying combined geometric characteristics without reference to temporal change or geological interaction. Interface-defined structural zones classify submarine forms based on the presence of distinct boundary regions where different structural types meet. These zones are identified by transitions in geometric configuration that create definable interfaces between adjacent forms. The classification is based on boundary characteristics rather than the individual forms on either side. Primary interface-defined categories include zones where two contrasting structural geometries meet along a continuous boundary. These interfaces are marked by a change in surface orientation or form type across a defined line or area. The classification focuses on the interface as a structural feature rather than the adjoining forms. Segmented interface categories include zones where boundaries between structural types occur in discontinuous sections. These interfaces appear as separated segments that collectively define the transition between adjacent forms. The grouping remains based on the presence of repeated boundary segments. Gradient interface categories include zones where structural transition occurs gradually across a defined area rather than along a sharp boundary. These interfaces are characterized by continuous variation between differing geometric forms. The classification remains within interface-defined zones due to the presence of transitional regions. Subcategories distinguish between single interface zones and multi-interface zones. Single interface types include structures defined by one primary boundary between two forms. Multi-interface types include configurations where multiple boundaries intersect or occur in proximity. Additional distinctions include linear interface zones and irregular interface zones. Linear types include interfaces that follow a consistent directional path. Irregular types include boundaries with variable orientation and non-uniform geometry. All interface-defined structural zones are characterized by the presence of identifiable boundaries between differing structural forms. These categories provide a consistent framework for classifying structural interfaces without reference to temporal change or geological interaction. Multiform boundary systems classify submarine structures where multiple distinct forms are connected or organized through shared boundary relationships. These systems are identified by the presence of interconnected edges that define interactions among several structural elements. The classification is based on boundary networks rather than individual form characteristics. Primary multiform boundary categories include configurations where three or more structural forms meet along shared boundaries. These arrangements create junction zones where multiple edges converge. Each form retains its geometric identity while participating in a combined boundary system. Network boundary categories include structures where boundaries form interconnected pathways linking multiple forms across an area. These systems exhibit repeated boundary connections that extend beyond isolated interfaces. The classification is determined by the continuity of boundary linkage across multiple elements. Segmented boundary system categories include configurations where multiform boundaries occur in separate clusters. Each cluster contains multiple interacting forms, while gaps exist between clusters. The grouping remains based on the presence of multiform boundary interaction within each segment. Subcategories distinguish between ordered boundary systems and irregular boundary systems. Ordered types include configurations with consistent boundary patterns or repeated junction structures. Irregular types include systems with variable boundary orientation and non-uniform connections. Additional distinctions include centralized boundary systems and distributed boundary systems. Centralized types include configurations with a focal junction, where multiple forms connect. Distributed types include boundary interactions, spread across multiple locations without a single focal point. All multiform boundary systems are defined by interconnected boundary relationships among multiple structural forms. These categories provide a consistent framework for identifying complex boundary networks without reference to temporal change or geological interaction. Across this classification system, submarine structures remain organized through form, profile, and arrangement alone. Each category exists as part of a broader framework where different structural types can be compared without reliance on location or measurement. The patterns remain consistent even as individual forms vary. This structured view continues across other topics within the same system. If you would like to follow more classifications like this, you can subscribe to the channel. You may also leave a like and share your thoughts or observations in the comments below.